So, welcome back, everybody. So today we will be talking about the mysterious Arduino, which you may have heard about on various occasions, and we've sort of been dancing around for your previous gadgets. We're going to talk about what Arduinos are and when you may or may not want to use them. But first, let's just do a quick review of what's going on in terms of the course curriculum. So, the Gadget 1 housing homework assignment is due today, which was to add that section onto your project page for Gadget 1 with the housing that you made for your gadget, etc. On Wednesday, the Gadget 2 use case will be due, so that's you coming up with the general idea for what you're going to be doing for Gadget 2. The library parts homework assignment, which is to create a couple of library parts in Eagle, will be due this Friday, and the parentheses for that is somewhere there too. And Brian is going to talk a bit about helpful checklists for getting your Gadget 1 to turn on without exploding.
Yes, if you want to just go to the website real quick. For Gadget 1, I realize you guys, all of you have picked up your boards. That's a good step. Half or most of you have ordered parts. I hope all of you have ordered parts to this point. It's very hard to assemble your board and get it working if you have no parts. But in course documents, we have a couple things. Board assembly checklist. Tom and I, like office hours in the evenings on weekends, just don't work for parents of toddlers. But basically, we sort of have our helpful board assembly checklist. A lot of this is very common sense, like go get all your parts, put them on your board, solder them to your board. But then they get to sort of some things that maybe are helpful to do before you plug it in. So before you plug it in, you take your big power supply and plug it into your gadget and plug it into the wall. Maybe you should check and make sure that your VCC and ground are not shorted together. That may mean you misassembled something or solder somewhere, because it's very bad to let out the magic smoke on your board before you've even done anything. So there's just sort of, and these are sort of in order, and they're sort of in order on purpose, so that you put all your parts on your board. Once everything is on, except for your batteries and your power supplies, then you check your power stuff. Make sure that your unregulated power to ground is not 0 ohms. Your regulated power to ground is not 0 ohms. And when you verify these things, then, and only then, do you plug in power. And it's very important that you not just say, well, I'm going to have a USB cable in my gadget. Let me just use my computer. Surely that's a regulated power supply that's good for development and testing of electronics. The answer is no, it is not. Unless you didn't care about your computer. Anyone ever tried to replace a USB port on a computer? It's very annoying. If you have a laptop, guess how hard it is. So I don't know how much your laptop costs. I don't know if it's worth a trip down to the REL to use a current limited regulated power supply. Might be. It's not my laptop. But basically, we have little power supplies so that when you plug your gadget on, and then you see the current meter go from 0 to infinity, you won't plug it real fast. There is sort of these steps you do when designing and building stuff for the first time, and it's very important to sort of follow through them. The TAs, that's basically what they've been doing, is helping people get this stuff put together. So if you've not visited your friendly TAs in the REL, that's a good time to visit them. Say, I think I started this together. I'd like to turn it on and make sure it doesn't blow up. They will cheerfully help you, because getting from the pile of parts to my gadget turns on, I can reprogram it, and the LED is blinking on it now. Like, there's a little bit of electrical details that you might want help with. So here's a checklist. Here are the TAs. They show up at regular times in the REL. Please use them.
Okay.
Yeah.
So, okay, cool.
Now back to your regularly scheduled Arduino lecture.
All right. How is progress on Gadget 1 going? You guys, everyone getting somewhere on it? Something like that? I see some nods, I see some shakes.
Has anyone blown anything up yet?
Just for us to get a piece.
Has anyone programmed their microcontroller?
All right.
Hooray.
Awesome.
Okay. If you have not ordered your parts, you really want to do it now. I really don't want to have to go back in and say, okay, everyone send us your parts receipts confirmation so that we can grade you on, did you order your parts in a timely fashion? Did you assemble your board in a timely fashion? We'd like to just trust everybody and say, you know, it's going to be for this deadline. We're going to give you a couple weeks breather. You got to build your housing. You know, there's sort of the, do we just give you credit at the end, or do we have to meet it out in partial credit? We'd like to trust you, but we don't want to let you guys hang yourselves on Gadget 1. Gadget 2 is when we let you hang yourselves.
All right, so now that we've answered that delightful discussion, let's go back to Arduinos. Let me go in order. All right, so what is an Arduino? So we've mentioned it a couple of times, and an Arduino is actually the name for a set of things. So there's a company called Arduino that made a board called the Arduino, and a development environment called Arduino, and an open source specification for Arduinos. There's a little bit of a namespace conflict. But basically, the Arduino ecosystem refers to all of these things together. So this company, the boards that they make, their programming development environment, and it all sort of works together. The basic idea is that, for some reason I keep skipping slides, this Italian company, Arduino, basically was a bunch of engineers, and at some point they got together and they made a gadget, just like you guys are making a gadget. And they made a gadget and it had a microcontroller and it had some random headers on it for pins and things like that. And they released on the market, and at the time there were a lot of different microcontrollers on the market. But then they did something which no other gadget manufacturer at the time was doing, which is that they actually started releasing helpful information on how to use their gadget. And they created helpful code for people to use with their gadget. And the long and short of it is that this was widely regarded to be a good idea. And so they were highly successful, and people started using their gadget very, very much. And they started making different variants of it in different sizes and things like that. They open sourced the design, and other people started copying their gadget. And so now, basically, the Arduino is this ubiquitous base gadget that you can use for a lot of different things. And it comes in a lot of different variants for particular applications. So to give you some example of that, we have here two different Arduinos on either end of the spectrum. Both of these are name brand Arduinos. We have the Arduino Mini, and you can see it's 2 centimeters by about 3 centimeters. It's a really tiny board. And it just has a microcontroller and a couple of little things on there, like a button to reset it, and an LED and a couple of capacitors. So basically the idea is you can plug it into something else. And it's really simple, and it has 8 analog pins and 14 digital pins. It's very similar to what you guys were making for Gadget 1. On the other side, we have the Arduino Do, which just came out. And this thing is kind of a monster. It's an 84 megahertz ARM processor, so this is closer to like a cell phone on a board. It has 54 digital I/O pins. It still only has 12 analog input pins and 2 analog output pins. And so the one on the left is about $10. The one on the right is about $80. And so this is like 2 of the Arduinos that are available. So Arduino took this very interesting approach to making their Arduinos. Yes, this is going to happen throughout the lecture. The name is going to be said many times. In that they open source all of their designs. So every time they make a board, they also release all of the files they use to make the board. And they actually use Eagle for making all of their boards too. So if you go to their website, you can actually go click a download link and get the Eagle files that they used to make their board. This is the 2009 Arduino, and as you can see, it's a little bit more complicated than the gadgets that you guys were working on. But basically, all of the same parts are there. So over here, this is an Atmega 328, so the same processor that we've been using for the most part. And we have over here a serial to USB chip, which lets you communicate to a computer. And then we have a voltage regulator up here, and this is just a little bit of power switching stuff. But this is the whole schematic. This is an Arduino right here. So you guys made about 80% of this thing on your last assignment. So how come Arduino is making tons and tons of money doing this and we are not? Well, it's because of the other things that they've done to make this easy for people to put together to create gadgets. So suppose I want to build a robot right now, like it should be able to drive around. Let's say we want to have a gyroscope on it so that we can tell which way we're facing, and we want to have wireless communication. So this would be like a pretty solid Gadget 2 project. But the caveat here is I don't want to do any electrical work. I don't want to do any soldering. I don't want to fabricate any boards. I'm super lazy. I have no idea what I'm doing. So how can I do this using just Arduino? Well, I can go over to one of many websites. In this case, I'm going to use Robot Shop. If I can spell it. Come on, Robot Shop. Okay. Robot Shop is a helpful Canadian supplier of many robot things. And let's get some robot parts. So let's see. So we need it to drive, so we're going to get some motors. As soon as they load, if this gets too slow, I'll just cheat and go to my answer sheet. It looks like Robot Shop is being slow. Okay, here we go. Yeah, let's get some motors. I don't really care what they are. Oh, let's get a propulsion kit. That sounds exciting. No, we're not getting a propulsion kit. Oh wait, these are cheap enough. Okay, this is not exorbitantly expensive. And I'm lazy, so we're going to add that to my cart. Yeah, sure. Product options. Let's get it in black. Okay, so now we have a robot which can drive if we had anything to control it. So I added 2 wheels. Okay, so now we start getting into why Arduinos are really useful. So now I want to add a microcontroller. And I'm going to use an Arduino microcontroller. And there's these things called shields. The basic idea is that Arduino made all of their Arduinos have roughly the same connector specification on the top. And they started turning out these things called shields, which do useful functions for a variety of general purpose stuff. So what I'm going to do is buy an Arduino and a couple of shields. So let me open both of those up. So here we have a variety of Arduinos. I'm actually going to just pick a regular Arduino here and add that. And when we get to the shields, what we'll see is that basically this encompasses a whole bunch of little modular functionality that's really convenient for us. So there are many shields that you can get, and lots of different people make them. But in this case, we're interested in getting a shield that will do some sort of motor driving and a shield that will do some sort of wireless. So we can find a motor shield. There we go. That one powers 2 DC motors. Perfect. So we'll add that to our cart. And let's see, we need a wireless shield. Let's use, this one looks good. Let's see. It's a Zigbee shield. We could also get a Bluetooth shield or a Wi-Fi shield. So let's add that to our cart as well. And let's take a look at our cart. I think that covers everything. I may have 2 copies of all of this in my cart when I was testing it out. No, maybe. Okay, so I got my wheel kit. I got a motor shield, which controls 2 things. Oh, I had forgotten about the IMU, but luckily Robot Shop saved my order. So I picked up an IMU Arduino shield, which has an IMU built into it, and a microcontroller, and a battery holder. See, I actually dumped a couple of extra things by accident. Okay, so that was it. I built a robot here. I just need to screw all these things to a plate of plastic or wood, and I'm done. And so that was kind of the thing that revolutionized Arduino's space, is that people who knew nothing about electronics at all could buy these modules and plug them together and have stuff. So in this case, this was about $200 worth of parts, and I would get this in a box, and I literally just plug them all together. They just stack. And so for about $200 in an hour, I have made a robot that has all these things. Now, there's a couple of caveats. I obviously have to mount all this together in a housing. And I obviously have to code quite a bit because I have an IMU, which is going to require a lot of code. And the Arduino itself doesn't do anything. It needs to be programmed as well. So this is where the second part of Arduino's magical mix of stuff came together, in that they made a development environment, and they made it really pretty friendly to use. Okay, so say we ordered all of our parts. We didn't, but I'll pretend that this is all of our parts. This is an Arduino, and let's try doing some coding with it. Okay, so you guys are all familiar with running AVR GCC and what it took. So now let's run Arduino. Arduino. All right, there we go. It's a box. Here's a box where you put code, and some boxes at top to do things like verify that your code will compile and upload it to a microcontroller. So I also have a giant list of example codes for doing all sorts of stuff that microcontrollers might want to do. So for example, we can do, say, basics link. Here's some sample code for blinking. Let me see if I can make this a bit clearer to read. Is that better? Yeah. Okay. So here I've just pulled this up. This was not something I wrote. This was just some example code that came with the editor. And the actual code is similar but simpler than what you guys had to do for your blink test. And the reason is because in the Arduino environment, they produce a set of library functions that simplify all of the basic things that people have to use on their microcontroller. So if you guys remember doing your port B tilde equals and port B and equals and or equals for doing stuff, and DDR and things like that, they wrapped those into functions like pin mode. So pin mode is essentially the data direction register that you guys were using. But they just made a nice little function for it where you specify a number and input or output. And it does the same thing, but it looks a lot cleaner. And then you have digital write. Well, that makes sense. That's how you write to a digital pin. And I want to write to the LED pin, and I want it to go high. And I want to wait for a while, so I'll do delay 1,000. All right, so this looks good. Let me just program it. So I hit program. A bunch of errors occur, but that's just because my computer's broken. Ignore those. Done uploading. Awesome. And here we have blinking at 1 hertz in 0 lines of my code. So that seems pretty awesome. And we can actually go through some of the other things that we've been discussing in class, such as, for example, serial. So let's pull up some example serial code, and I'm going to modify it to do something interesting. All right, so we have serial call and response, blah, blah, blah. This reads a bunch of, basically it reads a bunch of sensors using the analog read stuff. I don't care about that, so I'm just going to delete it. I'm going to delete all of this stuff that I don't care about. I have no idea what that's about. All right. So let's make a really, really, really simple function. And this function is going to, I don't have a digital sensor, so just get rid of that. Let's see. Okay, if we get a serial byte, then I'll read it. And let's make a switch case. So, or first, let's just write out something. Let's see. Do serial write. Let's see if this works. Yeah. And let's simplify this code just to. Okay, so I made code which will open my serial port and wait for it to come online. And then I will loop. And if I get a byte from the serial port, so this is me receiving a character, I will read it. And regardless of what it is, I'll write banana. So ignore this comment, replace with write banana. Wow, I'm terrible at typing today. All right, I have no idea if this will work. Let's try it. Oh no, invite was not declared in scope. Okay, that's happier. Great, done uploading. Well, let's see if it worked. They have a helpful serial monitor, which is now connected to my device. So let me see if this works. Wow, that's great. Bananas. pretty cool. Let's make it more complicated. All right, so let's do different things based on what we get. So, what are some good functions we can do here? Any suggestions? B for banana, I like it.
Capital B as well.
Capital B as well? All right, I don't want to get too confusing. I'll just leave it as one B right now. All right, who wants to name their next function? Any other characters that we want to use? No? C for cake. All right, let's do it. Great. All right, let's see.
Toggle the LED.
For dragon. All right. And you wanted to toggle the LED? Well, that'll be a little, let's do that in a sec. Let's just make verify cake and dragon, and then we'll toggle the LED. All right, cake and dragon, come your way. Upload. Awesome. Now, serial monitor. All right, let's try this. B for banana. All right. C for cake. D for dragon. E doesn't do anything. Excellent. Wow, look at that. So we made a function which does this interesting stuff. Okay, let's interface with our LED. So let's see if I remember how this goes. Our LED is on pin 13, which is helpfully labeled on my board, so I can just read it. 13 LED, great. Okay, so we want to set the pin mode on this guy. As an output. And, okay, what should turn on our LED? Let's make a command for that.
L.
L for LED, makes sense.
Toggle it, or just the?
We could. I'd have to read the pin, but let's see. Let's just toggle it using,
Capital.
yeah, capital and lowercase L for now. Okay, so this is going to do digital right LED pin. What do we want? This is turning it on, I guess. And this will turn it off. Got some characters. Okay, great. All right, let's program that. So now, let's see, we should be able to get serial working and also our LED. Okay, done programming. Connect to our serial monitor. All right, let's verify banana works, cake works, dragon works. All right, L. All right, this is really tiny, I know. The tiny green LED there, I can turn it on and off using my magic serial interface. So there you go. That wasn't too complicated, right?
Now, just to, for all your homework assignments, what's the actual code ends up looking very similar. Like I think if any of you checked the main functions, they were very similar. They have switch statements. We called a setup that called all of your ugly code. So all the ugly code is still somewhere.
This is still AVRGCC. All they've done is they've taken those functions that we were doing and they've wrapped them. And we're going to discuss in a bit why that is sometimes a good thing and sometimes a bad thing. But the long and short of it is they made this IDE, they spent a whole bunch of time making it so it's nice and blue and installs correctly. And it makes it pretty easy for people who have no idea what they're doing to do stuff, which is why it's become immensely popular. And so, let's hop back to our presentation of stuff. And so, okay, we looked at Arduino. Okay, it seems pretty good. So why on earth isn't everybody just using an Arduino? Well, there's a couple of trade-offs that come about because of them using this library functionality and them needing to make it so easy to use for everybody. Now, the first thing is that they had to limit the onboard functionality. So if you look at the chip that they actually use on an Arduino, Duo Milanove, or mine, etc., it's an Amiga 328, which is the same as what's on the Mini Gadget, I believe, more or less.
Mini Gadget's more mini, but
Okay, but it's very similar. The chip, if you look at the data sheet, has 23 I/O lines. between 6 or more PWM pins, depending on the exact configuration, and 8 analog inputs when it's in its TQFP package, which we went over before, is one of the packages that we could use. The Arduino Duo Millenove has 14 digital I/O, so like half of them are gone. It still has 6 PWM pins, and it only has 6 analog inputs. And this sort of holds true across all of the Arduinos. If you go through all of the sizes and you compare the processor that they're using on board to what their specifications are, you'll see you're only getting a small subset of the functionality available. And the reason for that is because they have these library functions and they can't deal with complicated stuff like a single pin being both an analog pin and a PWM pin and a digital I/O pin, what they did was essentially just hard code in certain pins having certain functions and not letting you change around how that stuff works. Now that makes their function calls really easy because now, when I have an analog read, it will always take an analog pin and there's just nothing around it. You don't have to think about it, it'll always work. But it does mean that all of those analog pins are now pins you can't use for digital I/O anymore. Even though the microcontroller is fine with that, Arduino is not fine with that. And so essentially you're sacrificing a portion of this functionality so that their code is easier to use. Now the other trade-off that they make is in the performance of their code. So you guys, for your example, or for your homework assignments, have been doing stuff like what's on the left. In AVR GCC, you're writing to a register, you're using a bit operation, and you're telling this register to change to high or low or whatever. In Arduino, they have wrapped that in a function call. It looks a lot simpler. You just put it in a pin, whether you want it to be high or low. You actually measure how long this takes. The stuff that you're doing on the left, which is the actual calls to the microcontroller registers, are taking about 350 nanoseconds per instruction. The ones on the right, being done by Arduino, are taking 3,800 nanoseconds. They're over 10 times slower, which means that if you're trying to do something fast on your Arduino and you're calling Arduino functions, basically they're wasting a lot of time that you didn't actually need to be wasting necessarily. Now, yeah?
Sorry, is that performance hit still present when you use port manipulation directly in Arduino?
No. So the reason for this slowdown is because of what Arduino is doing to idiot-proof itself. Essentially, every time you make any of these Arduino calls, because they assume that you have no idea what you're doing, they do a bunch of checks to make sure that the intended output, or the intended result of the function will happen. So every time you do a digital write, what they're first doing is checking out if you need to do anything to change this pin from having been set up as a timer or PWM or something specific or anything like that. It checks if it's a pin or not, like if you put in, digital write banana, it will sort of just let you go and not do anything. It turns off PWM if you're running PWM at the same time. And then it basically does exactly the same thing as what we were doing in the middle here.
And it turns off interrupts.
It turns off interrupts while you're doing it
Which
because,
may not be what you wanted.
yeah. So it's doing all this extra stuff. And it's nice because if you didn't know what you were doing, then that's great. If you were accidentally using this pin for like 8 different things, it's still make the digital write go through. But at the same time, it means every single time you're calling a digital write, even when it's in a tiny loop that's just turning on and off an LED, it has to execute through all of these checks. And all of their functions are like this. So you have to make this trade-off when you're using Arduino, but the nice part about it is it makes a lot of your code a little bit more robust in various ways that you may or may not have thought. On the other hand, if they're doing something you don't want, it means that they may secretly be doing something to screw you up. So for example, here, they're turning off interrupts while they change a pin, which may screw something else up that you're doing that depends on interrupts. Like perhaps listening for that interrupt change somewhere else, and now it may or may not trigger. Or perhaps for some reason you wanted to change the digital out, but you also wanted the PWM channels to be changing it as well.
What they're doing is they're being super paranoid and making sure that in some other interrupt you are not relying on this pin or changing it. And so they're being super paranoid and disabling all interrupts so that nothing else can be happening while this is going on. But then if you're trying to turn this pin on and off very quickly while also doing things using the interrupts, you're sort of killing yourself. So anytime you're trying to get any actual performance out of this, which doesn't describe any of your homeworks, right? Where it was the Arduino, the 18 mega was basically sleeping 99% of the time, and you were blinking an LED or waiting for a button. But for performance stuff, this can get very tricky.
Yeah, the other downside of this is that if you want to do something like having analog reads happening in the background, or waiting for interrupts to trigger things like serial port reading and stuff like that, Arduino just doesn't have those functions. You just have to use what they have, or you have to use your own stuff. So, let's see. So let's put this down to what exactly makes Arduinos useful or not. So the advantages of using Arduino components in your designs, the biggest one is probably that other people use them. If there's some sort of hardware on the market, or some sort of device that, like an accelerator, basically anything on SparkFun, there's probably sample code for how to use it on an Arduino, because so many people are using it. And if you're posting on forums like the SparkFun forums, or Society of Robots, or wherever, other people will be able to have some idea of what you're doing and usually can provide help readily. There's a large user base of people that know Arduino that may not know AVR-GCC or any specific microprocessor language. Of course, the big caveat to that is, well, if they only know Arduino and have no idea what it's doing under the hood, they don't necessarily always know what they're doing. You get lots and lots of buggy Arduino sample code, or really inefficient Arduino sample code that gets posted and that people are using for ages and ages when it's doing really strange stuff like just having while loops in the middle of it for a while, or just reading things over and over again for no reason. So there's the big caveat of, well, these are a bunch of people who have chosen Arduino because they aren't as familiar with microcontroller programming and you're using their code. The other big thing to note is that there are lots of manufacturers which cater towards Arduino. So there are lots of shields available and drivers available for using things like accelerometers, gyros, wireless modules, and things like that with Arduino. And it's a lot easier for you to find someone who's adapted these two things together. There's actually a whole market for third-party vendors that do nothing but take a device from a manufacturer and put it onto a carrier that can be used with Arduino. And if you search sites like SparkFun and Robot Shop and so forth, they're filled chock full of them. So that's why you would want to use an Arduino. But then why wouldn't you want to use an Arduino? Well, as we discussed before, you have this limited functionality. So in order to make things simpler, they basically hid most of the functionality of these microcontrollers. So you can't do things like asynchronous reads. You can't do things like using a pin for multiple functions, even though it's allowed by a microcontroller. The other thing is that you're going to take up lots of extra space. So when we were looking at our diff drive robot, which is entirely within the realm of what someone might be doing for Gadget 2, we have all of these boards, and each of these boards is about 3 inches by 4 inches, and they're all stacking vertically. In this whole assembly, we basically needed about 4 different parts. We needed an Arduino, we needed a motor driver, we needed an IMU, and we needed a Wi-Fi module. You could fit all of those things into the space taken up by just the Arduino, right? And now we're making a huge block, which is basically that space times another 3 inches vertically to do the same thing. And we're also adding a lot of cost, because on this entire motor shield, we needed maybe a $2 or $3 motor controller off of that board. On this 6.IMU shield, we needed just the gyro, which we could have gotten for maybe 10 or 15 bucks. And off of this Arduino compatible Wi-Fi microcontroller board, which is a Wi-Fi module plus an Arduino, it's basically a microcontroller, which is maybe 5 to 10 bucks, and a Wi-Fi controller, which is maybe 20 or 30 bucks. So you're paying for extra stuff at each of these levels in order for you not to have to deal with putting this all together. So you're taking extra space, and you're taking extra costs. Now the trade-off is, of course, I was able to do this really, really fast. So you're trading off your time for these things. Basically, you're paying some other engineer at some other company for the time it took him to make this shield instead of the time that you take to make it yourself an equal. Yeah, so in general, Arduino componentry is going to be more expensive than you making the same part yourself. How much more depends on the module and how many non-name brand knockoffs there are of it. So things that are really common, like Zigbee modules, for example, the market's become really competitive for those, so they're not that much more expensive than just buying the underlying module. And Arduinos themselves have actually been driven down in price because Arduino open sources their designs, and lots of third parties, for example, this is a DFduino, which is made by DFR, which is a company in Germany, is basically exactly the same as an Arduino, except like $5 cheaper. And so Arduino can't really check their prices because everyone just copies their designs and sells them alongside Arduino. But basically you're looking at shields are going to be between $10 and $60. And keep in mind, each shield has maybe one or two functions. So you have a shield and it does something like Wi-Fi, or a motor controller, or an accelerometer, and nothing else. And then Arduinos themselves can range depending on how complex they are. So for something small like this, which is just a very tiny microcontroller, you're looking at maybe $15 to $20. If you want a large Mega, which has more pins, or the Cortex one, those are going up to $80. And if you want stuff like built-in Wi-Fi or built-in Bluetooth, those go up to $200 or $250 for just the microcontroller plus the module, which you could probably buy both of those for $50 if you wanted to just put them together. So, oh my God, why aren't we using these in class, right? I'm sure some of you are like, oh my God, we've been doing all this Gadget 1 stuff, and it would be so much easier with Arduino. And you're right, it would be, but what we want you to learn here is how all of the underlying stuff works. So Arduino libraries, and I'm not even saying this figuratively, they literally wrap the exact same things that you've been learning this whole time. So when you see a digital write function, now you can go in there if it's doing something weird and look at it and say, oh, this is doing some extra stuff I don't need, and I can rewrite it this way. The other big thing is that even in Arduino, because they're using AVR GCC, you can program the same stuff that you've been doing, which is in AVR GCC, and Arduino's compiler will just happily take it and spit it onto the microcontroller. So if you are now working with Arduino, and you decide that that digital write function is really just too gosh darn slow, you can just put in port B or equals 1 and dump it in the middle of your code, and it'll work fine. So we want you to understand how the things in Arduino are working, because that will let you figure out what to do when their functions either don't work or don't do what you want, or you find sample code online and you don't understand what it's doing. So going forward, you may come across a gadget for which you want to use an Arduino, and by all means you should. If it's doing what you want, and it's doing it in the best way for what you want. So now that we've gone over kind of what Arduinos are and all that stuff, let's talk about how you actually use them in your gadgets. So the first way to use an Arduino is what I was explaining before. You can literally just go onto some website and buy a whole bunch of Arduino junk and strap it together, and what you end up with is usually a stack like this. Like, this is pretty close to what our robot that we designed at the beginning of class would be working off of. You have your motor controller thing up there, you have some IMU module in the middle, you have a communications module, you have an Arduino baseboard on the bottom that you can program. So it's pretty large. It's not getting any smaller. There's no real way to do anything besides those exact functions with it. But if I didn't know if this was going to work, if I just wanted to see if maybe I could make a robot that would be able to bounce off of walls, and I didn't really care about making any more than one of it, well, then this might be a good way to start out. So if you're not too concerned about space, you're just interested in figuring out functionality, interested in figuring out sort of the right idea for your gadget in the first place, and you don't mind the extra cost, just getting Arduino models and putting them together is a really good way to go. And it's really common on hobby sites for them to recommend that you do this for various things. The other thing to keep in mind is that the shields have to sort of do what you want. there's a little bit of a caveat in that these shields all just plug together on the same pins. And there's nothing really saying that they can't use the same pins or that they have to be compatible with each other. And so when you plug shields together, you have to be a little bit careful that they're not all using the same serial port or all using the same SPI lines, because then you'll just be screwed. And there's no real way for you to get around that aside from actually physically cutting and mucking around the ports. So it's sort of if you're lucky enough that your gadget is in the space of gadgets that Arduino was expecting you to make, then you're sort of set. You do this, you spend a little extra money, you get your thing in a week, you plug it together, you're good to go. Now, okay, that may or may not happen. If it does, great. But there's another alternative, which is you can buy one of the smaller Arduinos, or you can buy a big Arduino too, and you can plug it into a custom design board. Essentially, you can make your own shields. There's nothing magical about them. Essentially, they're just pinning out the same pins as the microcontroller on your board. So you can take the open source design from Arduino, you can look at where the headers are laid out, you can make an eagle part for that, and actually just use that as a part in your own layout to plug against. And then you don't have to worry about some of the stuff like having a bootloader or initially programming it or getting the USB ports to work properly or things like that. So you can avoid a little bit of trouble when you're first making a gadget, or if you want to make a simple gadget that you can use an existing microcontroller on. And this is a really good option for you kind of know what you want, or you have a very specific set of hardware that you want to interface to, or a specific form factor, and you're willing to sacrifice a little bit of space and a little bit of functionality in order for you to just plug this thing in and have it be able to be programmed. So this sort of guarantees that that first step of you plugging it in and having something that can sort of talk to you over serial and stuff like that is all sort of guaranteed. You don't have to worry about it. And this is pretty easy to do, and this is actually largely what I do. I mean, these guys sort of poke at me for it, but I do design a lot of parts where I just will stick an Arduino in it, just so I don't have to deal with the hassle of actually doing initial programming and getting stuff up and running. I can kind of know, if I plug it in and it powers up, I'm going to be able to program it, I'm going to be able to mess around with it. Now, of course, the more complex option is that you can make your own Arduino board. There's nothing special about that either. In fact, if you look at the Eagle files that they're providing, they're exactly the same as the Eagle files that you're generating. In some cases, the Eagle files that you generate might be better in certain ways. So if you don't mind the fact that their firmware is going to kind of restrict what you can do with the different pins, you can actually take their entire schematic and portions of their layout and copy it into your own Eagle file. And basically, once you initially flash firmware onto this device, it will function exactly the same as an Arduino. You can use it in the Arduino IDE. You can basically treat it like an Arduino. All of the same code will roughly work if you use the same processor. You still have to sort of be wary of how they've assigned pins. So for example, if they've defined a pin as an analog pin, then by God, that thing is never going to read digital properly, because their firmware libraries will simply just overwrite everything that you were doing. But this is the most flexible option, and this gives you a lot of the benefit of both worlds. You can still use their IDE. It's really easy to use libraries and sample code, but you still get to pick exactly the right form factor and function and pricing for everything going on your board. If you don't like it, make a 328, it's too small. You can put a bigger chip on it. You can put a slightly smaller chip. It doesn't have to be the same series. But this is a pretty good option. And this is actually what we will be allowing in Gadget 2. So as to how Arduinos relate to Gadget 2, basically, since you're going to be putting an Atmel microprocessor on there anyway, you can totally copy one of the Arduino schematics to get an Arduino compatible microprocessor to be on it. And we'll be helping in a limited fashion in the sense that we'll make sure your board powers on and that the general programming works out, but we won't necessarily help you with any Arduino specific related stuff. And we're certainly not going to debug it if you stick their gigantic 84 megahertz Cortex on there and it doesn't work. Because, I mean, geez, there's like 100 million things that could have gone wrong there. But basically, if you want to use the IDE and play around with stuff, you have an option to, again, to sort of, your mileage may vary.
Yeah, so our theory is we don't want you just making a part and building a shield, but you can build an entire Arduino, which sounds scary, but you can literally take the Arduino and you already have an entire Arduino just by downloading the reference design. But what we expect is that you'd say, well, I'm going to actually make it so that there's an accelerometer just directly on my Arduino. Maybe there's a Wi-Fi module or whatever else you're interested in. Like you just,
or you want a different form factor than the standard
yeah,
rectangle.
you can have a circular Arduino. And people will say, where did you get that? You can say, well, I made it. And then when you get to the programming, you all have the ISP, and all you'll do is you'll use it once to put on the Arduino bootloader, and then you can use the Arduino infrastructure from then on out, which is why it's very handy to have an ISP. And if you only ever do Arduino stuff, and you say, oh, my Arduino stopped going, I'm sad. That's because you have no ISP, you have no way to like fix the bootloader or do anything about it. So that's what we're sort of thinking with the Arduino. So definitely, yes, take the open source reference designs. There are 87 million Arduinos now, so pick and choose whichever one you want. Do you want USB? Do you want the tiny chip? Do you want the big chip? And go wild. And we expect you'll add at least a little bit of extra functionality to it.
Yep. If you're making all that, you might as well dump on the 2 or 3 other things that you were going to make on your gadget.
You're not just going to take the open source design, change the text on it to your name, and say, great, I'm done. This is the easiest gadget to ever. That's not going to fly. But there's no reason for us to not let you guys use Arduinos. In the past, people have grumbled furiously or less furiously that we're sort of hamstringing you with these like regular processors and not letting you use the Arduino programming environment. And in theory, you might even be able to make something that doesn't look anything like an Arduino and still use their environment. But that's sort of beyond the scope of what we can help you with.
I believe the modern IDE actually supports Everest 1.2 these days.
Okay.
It's getting pretty full featured. So the basic moral of the Arduino story is that they're out there and they do a lot of the same stuff as what you guys have been doing. So think of them as a tool in your arsenal to save you time and money. In situations where you're prototyping, in situations where you don't really care about the form factor and you just want to get stuff up and running, an Arduino is a really good option to get you a huge step of the way there without you having to do much work at all. But don't use them just for Arduino's sake. Don't use them just because like everyone's using Arduino and it's totally the right way to do it, that I'll make a stack like this tall of shields and none of them work with each other and they cost me like $800, which people do. If you Google Arduino shields, you can get people who are doing really, really dumb stuff like making Beowulf clusters of Arduinos. It's like, oh yeah, I put all of these together and I have the total computing capacity of my calculator. Okay, great. It cost you $10,000, and why did you do that? But Arduinos are useful in the right ways, and so hopefully at the end of the day, when you're going out and making gadgets after this class, which hopefully some portion of you will do, you can look at a gadget and be like, I see how I would make this gadget. I can also see that it would probably save me a bit of time and money to use part of an Arduino or an Arduino module or make a shield myself and plug an Arduino into it. And this is overall going to save me time and money in the long run of how complex my design is and what I need to put into it.
And again, this class, I don't know why, but we sort of skipped the prototyping phase of our design. Like we just sort of say, okay, nobody's breadboarding any of their circuits. We're just going to go straight into designing a schematic and making a custom circuit board. But Arduino is a great way to prototype slightly more complex stuff. But again, you're building a gadget, you say, okay, we've tested it on the bench. We have the Arduino, skyscraper here that does everything we want. But now we're going to make like 300 of these for some project, and like they have to fit in these little boxes. That's where this stuff comes back in when you say, wait, are we really going to try to just fit all this stuff in here, or am I going to just grab all these open source schematics, copy and paste all the circuits I want into one schematic, lay it out to fit our thing, and you can still use the Arduino programming language, you can still use all of the Arduino reference designs, You've just made the thing, you know, an actual useful gadget that's going to be cheap to make in large quantities. You sort of optimized all the little corners of the design. Now that you know what it has to do.
So anyway, it's a short lecture on Arduinos. I'm going to spend the rest of the lecture going to do a live session of copying that schematic over, fiddling with it a bit, and messing with the coding. We can show some examples of specific digital communication stuff.
So is anybody excited about using an Arduino for Gadget 2? Is anyone going to do it anyway, even if they're not very excited? Wow. So it's an option, and you know, if you hate the programming stuff and you want to use the pretty blue IDE instead of the crufty WinAVR stuff, that's pretty cool IDE. I mean, I think Programmer's Notepad has the colors too. And if you go up to the programming, make program, it kind of does the pretty sketch, compile, and verify. We're ignoring the red stuff at the bottom, just like the other one. Yep.
Sorry, so just to clarify, so we're allowed to use the actual Arduino boards, or we design your own Arduino?
You can go get a reference schematic from your favorite Arduino,
Okay.
and if you don't mess with the schematic and lay out too much, what you're going to do is then add in whatever else you'd like. So what we're saying is you can make an Arduino, but not an Arduino shield, if that makes sense to you.
Okay.
So you can't go and buy an Arduino board and then just make a board that sits on top of it. That's
Okay.
not.
Okay.
But what we can tell you is that if you take their reference design for a standard
So
Arduino,
we're still thinking our own?
yeah, presumably you'd add some extra stuff. So like just put your LEDs right on the board, put your accelerometer on. And then as long as you didn't poke at too many of those programming lines, the weird circuits they add that you don't quite understand, if you don't mess with those, we can put on their bootloader using the ISP, and then like, it's an Arduino, it just happens to have like special things on pin 15. And like your LED is like soldered onto pin 15.
Wait, so then it also makes it really much.
So if you like the Arduino programming, you want nothing to do with our devilish port B or equals blah, and you never want to see that again, this is your way out.
Okay.
Yeah.
You only get a actually zero home because you are.
Absolutely. And again, it's all about, and we're going to talk about that. We're going to talk about specifically what kind of libraries, reference libraries you can use for the ATmega and XMegas. For Gadget 2, you don't have to sort of cobble everything together from scratch if you don't want to. And again, like the high level, like if Cross goes to his loop. Now, your homework, we sort of made you guys all just stay in the muck, with all the low-level function implementations. But if you went to the main functions, they looked kind of similar. Tom did this init function, which really just held all the other inits that you guys were writing. And then he had a void main, blah, blah, blah. But then it had a while one loop, which suspiciously, this one's called a loop, never exits, keeps running over and over again. Like, it's doing the exact same thing that Tom's thing is doing. And then, you can write this exact same code. Like, there's nothing saying that you can't have if serial available. I always use, if, byte read doesn't equal -1. It's the same sort of thing. Read the byte, switch the byte. There's nothing here. None of this is very Arduino specific. You would need to implement serial.write. In the AVR GCC world, there's this wonderful thing called printf. You may have heard of it if you've done any programming on a computer, where I would simply just say printf banana. If you have 7 serial ports, I would do fprintf, comma, ampersand serial 1, comma, banana. And it works the same way.
And internally, that's what they're doing. It's just here they've cleaned it up. They give you an object called serial and serial 1 and serial 2.
Yeah. So ultimately, you can make your main code look as clean as you like. There's no reason to make it, if you don't like how Tom wrote his code, you can, write it in a more programmer-friendly way. There's limited C++ support. You can actually do, serial.write if you really want, instead of just write serial or printf. But it all kind of works the same. But yeah, so if you want to use Arduino, there's no reason not to. And if you want to make it look like this, there's no reason not to.
So in Arduino.
Yeah, so in the other Arduino,
Now,
meanwhile in Arduino,
well, helpfully, the Mac puts the title bar on this screen and the rest of it on that screen, so
Yes.
this is gonna take a little bit of looking back and forth.
so we're gonna find the schematic.
Yeah, I can get this back. Okay. Oh, no, that's not the right one. Okay. Okay, so if we were, for Gadget 2, using this Arduino, we could probably just.
So what are those two pins right here?
Oh, yeah, those are on the FTDI chip.
Oh, that's the FTA, I'm sorry.
Yes. This is the,
F2 or F3?
yes.
Okay.
This is the Mega with all of its lovely pins, which you could simply pin out to things other than a connector. So if you wanted to put your potentiometer or something there, then you could do that. Now, the caveat is that it's going forward. These pins are normally programmable, but Arduino's firmware just assigns them random. So for example, these 6 pins up here are just analog. They will never work for digital. And if you put anything on them that is not something that you want to read as an analog input, then you can't do anything with it.
One thing I'll point out, Arduino, they're Italian. They use European electrical standards, which is why the capacitors look different and why the resistors look different. LEDs kind of look the same, crystals look the same. Stylistically, you can use whatever you're sort of stuck with. Please don't mix and match. It'll just drive us
Yeah,
crazy.
you'll notice it on your schematic when you have this.
So if your resistors look like this, don't try to find the package, just use the copy command and you can have however many extra resistors you need.
Or feel free to replace their resistors. There's nothing special about their resistors. They're just resistors.
Or you may find that they're using the giant sort of Duplo dip version of all microcontrollers, generally because they're cheaper to have someone assemble by hand. But if you want to have a much smaller board and you don't want to have Tom and I cry that you guys are using a through-hole dip, where did we lead you wrong? You can replace the package of this with a much smaller one. And you may find that you get bonus pins. You get 2 free analog pins that your Arduino knows nothing about. You could hook up to your secret sensors, and then in your code, you can modify these sensors and not have to worry about their Arduino overwriting them because it doesn't know they exist. And that may be even more the case on the larger Arduinos where they kind of said, well, we have the standard pin headers that we put everywhere, but we've got like 10 extra pins. Let's just leave them blank and not use them, which is what I think they must do.
Yep, that's basically what they do. The other thing that they do is just aggressively hard code the functionality of pins. So they'll just be like, these are the PWM pins, like all 20 of them. It's just, well, now you can't use them for anything else. They're just for that. Which is fine when you can't actually get those pins physically off the board. Just keep in mind, Arduino is really pushing everything onto these connectors. So anything they can't fit into their connectors is effectively wasted on their ports. So they'll just randomly assign stuff so they don't have any stuff that isn't getting routed to connectors somewhere. So we can take a look at the more complicated cortex, but I don't think it's really basically just this one.
Yeah, some setup stuff. So if you're copying one, feel free to add whatever you like on the pins. I'd recommend not monkeying with their infrastructure stuff. So the crystal, you want to leave that alone. The reference, the capacitor on ABCC, things like that. If you can ask us, and we'll tell you, what it's doing. We can sort of give you suggestions. Leave the poor regulator alone. Unless you want to use a nicer regulator, use a nicer power switch. Do they even have power switches?
No, they have the auto power switch for internal perception.
Yeah. So if you wanted to make an advanced Arduino, you could add the power switch, which is this complicated thing that lets you turn it on and off an electronic device. And somehow doesn't make it into any of these sort of low-level, used by millions of people or thousands of people, and they don't have power switches. So you can bring it to the masses.
Yep, so that's Arduinos. I'm gonna pass this around so you can take a look at it. This is an example of a nano Arduino and a shield together, which just pins it out. There's actually 2 components. So this is a small Arduino. This is actually the Arduino part. This is just a carrier board. This is a shield for this. So I'll pass this around so you guys can check it out. I think it still has the serial code, so if any of you have a serial port and know how to quickly get it up and running, you can play with it and have it do its ABCD cake dragon thing. But yeah, so basically that's the long and short of it. Arduino's website is helpfully Italian, arduino.cc. And if you Google Arduino, you will simply find them because they're everywhere. All right, there's Arduino.
Anyone not heard of Arduino before coming to this class?
All right.
Yeah, we didn't think so.
Yep. Has anyone not used Arduino? Okay. So now you have some idea what to expect. You can see that if you get to, they have a lot of reference material on their code, but this is mostly C++ and C code, but they're just like if statements. If you don't know how to use a switch case statement, go to their site and they'll tell you, which is kind of nice. I think one other thing, which I can find it here, Arduino does actually have a statement about using, here we go, so you want to make an Arduino. Basically what they say here is we do not care at all if you guys make your own Arduino. So just to clarify, we're not stepping on anyone's toes here. Arduino is totally cool with you guys making your own spin-off, rip-off Arduinos. And even with selling them, as long as you, if you're going to sell them, there's some licenses associated with it, which are basically just, you can't brand it as Arduino, you can't, steal their design and try and resell it. But you can sell boards, which are basically Arduinos, they don't care. There's a lot of helpful advice they have on if you want to license stuff with them, which I don't think you all ever do. Okay, so that's the end of my formal lecture, isn't it? Cool. Well, short lecture, I can answer questions about Arduinos. I've used them for many years. People are thinking of using them or using parts of them in your gadgets. I would be happy to answer questions about that now or after class, which are kind of the same thing since they were Android.
All right, any questions on, questions on Arduino? Questions on Gadget 2 in general? On Wednesday, we're going to talk more about the crufty monkey versions of how to stay with 18 megas and X megas, and how to do like high-speed stuff for those of you who want speed and not ease of use. Then the last thing is, anyone have any big problems with Gadget 1? Getting it ordered, getting it put together, turning it on, and having it stay on and not blow up anything. All right.
Actually, just a question about adding the housing design to our website.
Yes.
You're supposed to create a different section on your website, or?
No, just editing the text.
Edit the text.
Basically just,
Like
try to
clear the bottom.
make it clear.
So just, advanced Drupal-based HTML editing,
Okay.
new section maybe. Please make them readable. If it's just a block of text, it makes us sad to read, and then that kind of affects what we think.
When you edit stuff, do you get a little editor or?
Yeah, there's a
No, not just a box, but like
If you're having any trouble with the website,
fonts and stuff.
please do your best. You can also email us a copy at CB Gadgetry, but sort of use that as a last resort.
Yeah.
Okay?